if you will put like a PS command, like, right, then you can see what are all the processes running. Then you should be able to see, like, if I'm running one ROS node, then you should be seeing one more process there, right?
Oh, that tells you processes.
So the PID is different for everyone. For me, it says 11144719.
Yeah, that's the PID. Right? That's the process ID. It can be anything. Right? We're not like that is something your OS is controlling for you. So it can.
PS is the command to.
PS is yeah. I think it's
process systems or something.
PSAs for all and all. So okay, so ROS node, we understood what ROS node is. ROS core, it's the main process that maintains all the registry, right? So the first thing that need to come up in ROS is ROS core itself. Then any new node will come. As soon as it will come up, it will try to find ROS core. If ROS core is already there, then it will inform about its presence, and it will inform a couple of more information. This information is, okay, I want to read this channel and I will be publishing on this channel. So this is the information that it will. So ROS core will maintain this register. Okay. So in ROS we have like three main things. So ROS node is one. Then ROS topic.
Can you pull up that slide real quick? I think
oh yeah. Oh wait, that's correct.
That's actually the slide that I really want.
Right, so I copied this from internet, so I should have given reference part. Right, so let's see what happens, right? So these arrows that we going from one to another, these are normally channels. Okay, so these are ROS topics. We call them ROS topics. So the three new terms: ROS node, ROS topic, and ROS core. So ROS topic is the channel on which I publish to or I subscribe to. Right, that's the communication line, like it's like a telephonic line, and anyone can join that line. It's like all of us can speak at the same time, and on the other end, like all of them can listen at the same time. Right? So it's not like a problem, like how many subscriber or publisher are doing that, right? And then ROS node definitely there can be multiple ROS nodes subscribing to the same topic, doing different tasks. So that's the whole idea, right? So I'm just going through very quickly. So ROS core we have all done. Yep. So the first thing that comes up is ROS core. Then a node comes up. It gives a couple of information to ROS core to register. That is ROS, the name of the node, the topic that it will be subscribing or publishing to. Next node will come up. It will also talk to ROS core, telling its name, telling what channel I'll be subscribing or publishing it to.
So ROS master here is the ROS core.
Yes. Okay. And this ROS master, what ROS master will do it will already have a register of the first guy I've already told I'll be talking to that channel. This guy, a new node came up and is telling I'll be listening to that channel. So ROS will ask them to communicate directly. So ROS master will help them to establish a direct contact. So they need not, the final communication will not be going through the ROS master. But ROS master is kind of like every new node is coming and querying ROS master to know who else is publishing, to get to know, right? So ROS message. Okay, so on a ROS topic, so ROS topic is not exactly like a telephonic line because we can speak anything and everything, right? But on a ROS topic, there is a specific type of message you can put on. So it's not that you cannot put any ROS message on any ROS topic. So a ROS topic is associated with a message type. So if it's a topic that is for LiDAR message, then you can not put like camera images on that topic. So a message type is associated with a ROS topic. Okay, that's it. So we have learned 4 terms: ROS master, ROS core. They are same in nature. ROS node, ROS topic, and ROS message, right? And yeah, that's it. Let's go and make some notes and publish and talk to each other, right? So
okay. We git cloned your repository.
Yeah, you guys already did that, right? So so let's see how will I like start making it. So I'll go to home. Where is that i3 Detroit?
So the repository that you made, we are using that one, right? And we are using your subscribers and publishers,
That's correct.
right?
Mhm.
So if we had to make that by ourselves, like a repository, is there any tutorial like it's on the website?
Yeah, let's make them, right?
Or it's not use yours?
No, so we are not copying them directly. I am saying like we'll be just using them, but we'll make them from scratch, like
Oh.
on the site, right? I just wanted them for referencing. Okay. So let's see what that package I have already, right? So there is so now I can see what it depends on. It only depends on ROS CPP and standard messages. So how I would have created, I can go and because I don't use Python. So I'll go to source. Oh, no, CD Melodic Workspace. Source, right? Now cat can create package. Package name I'll keep same, topic publisher. Okay, and I can see like what I'll be using. I'll be using standard message and ROS CPP. That's it. Yes, I'll be using ROS CPP because I'm writing my program in C++. That's it. And standard messages, if I'm publishing or subscribing, I'll be using it.
So cat can underscore.
So very simple, yeah.
Underscore package. It's the same line, right? Two. Okay.
Topic.
No, topic, right? Okay, sorry. Topic.
Right.
Underscore publisher.
Yeah, you can name it anything. It's just the name of the package.
Oh, yes. Topic.
Okay.
So you're creating a
Created,
package
yeah.
inside source.
Yeah. Every time I always create a package inside source.
Great. But in your Catkin workspace that we downloaded from Git, I see different packages and then there is a source folder inside those packages.
Let me see.
There is a different file system.
I'll be curious
These
to
are
know.
all packages.
Yes.
And then if you click on any one of those, you'll see a source folder.
Oh yeah. So source is main source, and every package have a source folder itself
Yeah.
in which I'll be putting my C++ files.
Yeah. That's okay. But if you go back to the melodic workspace now,
Mm-hmm.
you'll have build, devel, and what is this? Source.
Source.
So there isn't any.
Oh, there is.
Inside that you have those packages
Yeah.
now.
That's it. Yeah.
So that's the difference between those two
No.
workspaces.
They're same. Yeah. They're same. I'm quite sure. Okay.
Mm.
So we were there, and now let's see.
Okay, let me see. Okay, successfully created files. And
Yeah, I will need them for reference. So I'll go to topic publisher. That is what we are creating, and then I'll So ls
Inside
CD
this, I already have
topic publisher ls. I'll go to source, and then I'll create a file.
wait.
Touch.
I went to top. No, there is no.
Yeah, that's just creating a
topic
file.
publisher package. No such file.
What is touch?
Oh, that creates a file.
Wait, I don't have.
What's the name? Simple topic publisher.
So melodic workspace source big topic publisher source will also have a file named the same thing, right?
So I have to go to source and then lscd topic publisher package.
Mm-hmm.
It says no such
I
file.
look into this, then I'll
Can I see your terminal?
Oh yeah.
Okay.
Did you try CD?
You did it touch.
Huh?
Why are you doing LS? Did you try CD?
So you'll be installing like Linux in the end, Alex?
Yeah.
I think right. Okay.
Yeah.
I mean, I have it, but it doesn't. It's not on the
This
part.
is working?
So I went to topic publisher and
Mm-hmm. And inside the source, I have created a file named topic publisher node CPP, in which I'll be putting my program now. I'll
so
be
within topic publisher there is a source.
yeah,
You have to go to source
and then create a file, a CPP file,
and then make there. or
not mkdir.
Or
It's a
server.
file.
Oh.
Mkdir creates directories.
that MK.
So you can do gedit or like touch. Touch creates the file. Gedit like it will open the file also.
So I should do gedit.
Yeah, you can do both, right? That's just an option. So I think I'll try to use Eclipse if possible.
Topic
No.
publisher. That's all.
Can you open that CPP file in
Topic
your Git?
publisher underscore node.cpp.
The Git one? Yeah, I'll be definitely doing
on
it.
the web page.
So I have to create topic publisher.
We can just copy that into a new
No, I don't want to do that. Like, let's build it like from. I'll see. You guys need not to copy because like then actually you can. So you already have that
Yeah.
actually. So you can copy that file. Yeah, I'll be doing that. Like I'll be seeing it.
Melodic workspace.
I mean, that's-
So we're done with the setup portion?
Yes. Now we are writing an actual node.
So okay.
Can we like take an example? Just I don't know. What do you guys think?
Yeah, that's why
do the
we
writing there.
we are
In 2
writing that
weeks.
example. We are writing.
Next time, or you want to do it today?
What?
The writing of the stuff. So we finished the setup portion.
Yeah, I mean we should go into topic publisher.cpp and write.
So that's
Yep.
not everything at once. Or you want to do this stuff today?
Oh no, I'm okay with anything.
I'm fine. Yeah, I'm
Very
fine.
good.
It's
Yeah,
I'm
now
fine. I think it's
yeah.
trivial. So
Okay.
let's do like at least create nodes so that we finish the basics of ROS, right? So at least.
Yeah,
Right.
that'd be good.
Maybe you
Well,
know
that's
what?
where, because I don't have it, like, we don't, like
maybe-
a couple of us don't have it installed, and I think like the setup portion you went through, I can
So
watch
this is
and set it
yeah.
up. And then this is the part, like, well, for me, but it's not just about me, obviously. So, like, I need to do this, follow you step by step.
Oh, okay.
So, like,
Yeah.
we'll
Or
need to
maybe
do
we
this again.
can meet on Thursday and we can do this again at your house.
Yeah, and that's why I was wondering if you could come on Thursday,
Well,
because then I need
yeah.
to finish all this setup, and then for sure I'll be good in 2 weeks.
Yeah.
Right. So are we continuing or what do you
Well,
say?
you guys,
You guys decide.
I'm okay
You
with
guys-
anything. Now I don't have to take permission to come here. She also come, so I can come any I can
As if
Will-
you take it
will-
every day.
will come any Saturday whenever we have it.
are you gonna set up your machine, or are you gonna leave it on Windows?
On Windows.
If you
Just
want
do
to
it
do
on
it on
Windows.
Windows, just install Docker.
Okay. I think I did. Like what do you call it? The distribution, Linux distribution, right?
Yep.
Dual boot?
Yeah, that okay.
Just do a dual boot. That's much easier.
Yeah. Or
We
do
can
it-
go through whatever you guys want to go through, but then I'm gonna probably try to ask you to do this again, start from where we are now,
Okay.
in 2 weeks.
Yeah.
So if you don't
Yeah,
mind
we
doing
can
it
do it
twice,
after
we can
weeks,
do
yeah.
it twice.
Yeah. Let me show the program though, right?
But if
So
you don't mind, like,
let me show the program
if
that.
we can start here in 2 weeks again.
Yeah. Let me show the program that we are about to see.
Alright.
Yeah.
And then I'll just copy and run them for you guys to see. I think I did that last time, and we can do that again. Just let me show the program. So I was writing publisher, right? Oh, not the subscriber. That can workspace and publisher. So let's look at like how the source file looks like. Very
So
simple.
that's it?
Yeah.
Oh man.
Right.
Include ROS, so you have a. this
Oh,
is a
do you
C++.
want to increase the
You-
font?
So in C++, you don't need the header files.
These are the header files,
Okay.
right?
Where did you write those? Where do they come from? The
They come from ROS.
ROS.
Yeah.
Oh.
Those are ROS header files.
Oh, so I guess that's the.
You remember?
second
Yeah,
one
we
is
installed
the
the standard
yeah.
messages.
Yeah.
We did that for this.
Yeah, and then the ROS comes from.
ROS is the basic ROS.
It's
If
already
you
there
want to
when you-
use ROS, then you have to do this.
Okay.
That's with every node, right?
Gotcha.
And then this. Let's start with my main,
I copy this. Okay.
Integer.
right?
Yeah, very good.
So what is this? What the main is?
It's the main program that runs, right?
And
That's
then-
like in C++.
What
Okay,
is the argument in the parentheses? Is that what it's called?
like this one.
What's the text in the parentheses?
ARGC, ARGB. Okay, so these are the default arguments that comes with like when you call a process, a C++ process from OS. Then these are the two things that you pass. So int ARGC gives you the number of arguments.
So is that integer? The int is for integer.
Yes,
And arg.
yes, and ARGB is like the name of the file. That's my understanding. Like right? And
So that's a standard line.
this line is standard. Like in C++, you will see that a lot.
Yeah.
We at times don't use it, but this is like a standard thing. I'll say this is a standard. Like every time you create a ROS node, you will always do these 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 lines, right? So okay, let's look at what this is the main call, and then every time you want to initialize ROS, you will have to do this. Like you pass those arguments argc, argv, and the name of this particular node.
What is the double colon?
This.
It's to describe a string, right?
Oh, I'm not that well.
Oh yeah.
I don't write code day to day, so.
Oh, so this is like so I'm passing 3 arguments to my init. First is argc, second is argv, and third is a string. So it's just a string. Like double colon is telling you this. That's a string. You can name it anything, but that will be the name of the node known to ROS. Okay, and then next command, until you declare a variable of type node handle, till that time this will not be acting as a node. Okay, so this is the main line number 7 is the command that declares this particular process as a node, ROS node.
Can we make those comments in this file?
Oh yeah. Let me do one thing. I think not here.
Maybe in your Git only you can we can edit or
I'll have to. I think I can.
You
do
can
it.
edit in here.
yeah.
Declares
You just have to commit it again.
node. Yeah, and this will be telling name of the ROS node. So this is the default name of the ROS node, but you can definitely override it by the commands that you will be using to call these things. Okay. Let me just commit this. Where's the commit?
Top, up,
Yeah,
yeah,
Hmm.
comment changes.
Comments. Okay, commit directly to master branch. Yeah, that's fine. Okay. Fine. So now we can see. I think. Okay. Now we are describing a publisher. So to declare a publisher, I'll have to declare a variable of type publisher, and this is what it is: ROS publisher, name of the publisher, and then there are things associated with the publisher. So what do I need to give? What information should be associated with the publisher? Just think about it, and then we'll see what are we adding. It should have
Like
the message that we are publishing.
Yeah.
It should have the name of the topic. And there is a concept called buffer size. I'll tell you in a while what that is, but that is all it is. Like it is telling this is the message type, standard messages integer 32, that's the message type. It's saying it will be advertising, like so it is templatizing advertise. Yeah, this is like some C++ stuff. But I'll rather, like, if you don't understand C++, I'll rather, like, always the template is same ns.advertise and then the message type and name of the topic and then the buffer size.
Okay.
That's it.
Yeah.
So buffer size, okay, what is buffer size? Suppose there is one publisher, one subscriber. Publisher is publishing at 100 Hertz. Subscriber is subscribing at 100 Hertz. Then the message and everything is like optimal. Then there will be no message leak, no delays. Every time a message will be generated, that will be consumed by my subscriber. So publisher will generate, subscriber will consume it. But suppose there are like delays. That is not a suppose, that is actually reality. Suppose there is like a 10%, I should say, there is a 10% variance in the rate of publishing. Okay, then there is a possibility that you can publish from 90 Hertz to 110 Hertz, right? Then you will like to have some kind of buffer to be maintained so that if my subscriber is not able to consume my messages at the same rate, we don't lose that information. Because if my buffer size will be 1, like, then if I did not read that within that time period and next message came in from the publisher, I'll lose the previous message. That's why we should have some kind of buffer. It's a function of the variance of, like, what kind of communication channel you have. Like, if rate can fluctuate actually in like real communication environments like Wi-Fi. We are using like Wi-Fi at times, so that's why we have to have some kind of buffer there.
So the 1000 units is hertz here?
It's 1000 units is the size of the buffer.
Like bits?
It's no, it's like it will save 1000 integer 32 messages in
So
memory.
Yeah.
Yeah,
It's like
it
a
has
packet,
nothing. Yeah, it's
1000
yeah,
packets.
it maintains a vector of that much length of that message. So if I'll have 1000 for LiDAR,
Uh-huh.
not good, because a LiDAR message is pretty big,
That's
right?
right.
So it's if suppose a LiDAR single read from a LiDAR is 1 MB,
Mhm.
Yeah.
then you are actually maintaining a 1 GB buffer, right? So now so it's buffer size, like it has nothing to do with rate. It's maintaining that, and it's a FIFO buffer. So if you are not consuming your messages, then what will happen is the previous messages will get deleted, deleted, right? So that's how things are working,
Awesome. Very good.
right? And then this is a functionality that I'm using from ROS. So
Every
I
2
want to
seconds.
run it at 2 hertz. I think 2 hertz. Yeah, this is like I want to loop at 2 hertz, and then I'm creating a ROS message of integer 32 type, a standard message count that I'll be publishing essentially, right? And this is like looping over it and publishing the count. Then again spin once, sleeping for some time, and then increasing the. So what it will do is it will print 0, 1, 2, 3 at 2 hertz. So it will increase the counter at 2 hertz. That's it,
Awesome.
right? It's
I saved it.
I think, yeah.
Can we make those comments also? Add those?
okay, yeah.
Like everything you just said is very important, but
Oh yeah.
it's gonna be hard
Yep.
to.
So this
like we actually went
let
over
me tell
quite a
you
bit of stuff today.
this buffer size I don't
I
like.
think we did this last week.
Yep, I think yeah, we did not go in that kind of
Because
detail.
we were,
but
I
yeah.
think, kind of.
We definitely looked into this code. Yeah.
Yeah, the 2 hertz, was it hertz or second?
Yep.
We were like.
Yep.
Yeah, but I bet we could do the same thing next week and then we'd learn new stuff again.
So
Yeah.
you talked about the LiDAR and the 1000. So
Mhm.
how do you decide the loop rate? Does that depend on the specification of the sensor?
Yeah.
We're only
Because-
talking about the sensors. I mean,
So
how-
specification of the sensor is a limitation,
Okay.
and that should always be less than what you require. So you suppose it all depends on your application. In the end, you will ask this question: okay, at what rate I need to process this? That's the basic thing that you need to ask. That's the first question, right?
Yeah.
So suppose you're planning like any algorithm to run at like 10 hertz.
It has all
Yeah.
Now that means that your sensor
the same price.
should be able to publish at more than 10 hertz, even maybe double to 10 hertz, right?
It's the same code.
Yeah.
With all
So your specification
it's in the raw
should not be limited by your sensor.
Mhm.
It should be limited by your algorithm,
Yeah.
and sensor
the
should be able to
similarity
take care of that kind of. So it
Yeah.
right? So
I think there are some messages which you need like some critical messages.
Uh-huh.
You need like
the count.
much faster than some messages.
yeah. So ROS2 is actually providing this kind of functionality. So when
Priority, I think you prioritize
Slightly.
yeah,
which is high.
right. ROS1 do not have a priority associated with a message type or topic. ROS2 have it. That's a very beautiful thing. Like when you are like flying a quadcopter, your communication message is going down, you will definitely want to have your control signals
So, at that
to be guaranteed rather than having like live feed and like of a HD video. So ROS2 is taking care of that kind of priority. It is in a way guaranteeing you one message over another, like, or it tells you I'm not able to guarantee. That is also important. That with this kind of variance in your communication channel, I cannot guarantee this rate. That is also something that you should be able to get from your communication channel or like from your package, whatever you use, ROS or something.
So would you be so like because you have your car that you're kind of building, right? So you build something, then you teach it. That'll make
Yeah.
you build your car, and then that'll
Yeah, I'm
in the end there will be a working thing, and then we can all build something.
Yeah, I think
Yeah.
I think our first target would be
Not
to
not not starting with 2 weeks. I think 2 weeks we should go through what you have. here.
Yeah.
Like
let's
still
see.
fundamentals before.
Yep.
it
Okay.
gets-
Makes sense. Yeah, next time I think even I'm busy like doing some other ROS stuff like online, studying some other thing. But yeah, we can do that. Like,
And then there's a working thing at the end of it.
yeah, I will rather
I
suggest.
think
I will
I
rather
think we-
suggest. Yeah.
What? I think we can target integrating the LiDAR into our donkey cars. Because we already know how
He
the
has a
old-
LiDAR on his car, and so he
Yeah,
would
it works.
basically teach us.
It works with ROS.
Which one did you buy? I mean, how costly?
It was $300.
That's what I told. He says like $300.
$300.
$300
Yeah.
like that.
Yeah.
Yeah, for a donkey car, I think a $50 one is good enough.
Yeah.
Or you can
But I
make your
think we
own
would
LiDAR.
need to buy one which is ROS capable. We need to do some research and understand.
Oh, definitely you need to.
We-
But I think all these cheaper ones will make sure that they are working with ROS, because only the ROS users will buy them.
Oh yeah.
I
Some high
mean,
users would buy it.
why will industry buy them? Like,
Correct. Yeah.
they are not industry worth for sure.
People
Yeah, so that's why they will guarantee that for. But yeah, you definitely need to research that and ask them. So mine have a library with ROS, though the company shut down. It's working.
There is support.
No support, but the library is still working, and I'm happy.
Manish,
Uh,
in that tutorial page,
let me run like, because very quickly you
tutorial
are here
number
for.
11, it's the same thing.
Let me run. Let me do one thing. Okay.
So just like we created a publisher, we can create even
Yes, and
subscriber.
exactly. What I will do is I will just copy them. Topic publisher and topic subscriber. Control C. Source. I'm deleting because I don't want to overwrite anything. And let me see if this works. Like, this is not the right.
By copy pasting.
Yeah. If cat can take care of it. Oh, what happened? Acha.
Oh, you have to do it.
If this works, then we are lucky. And I think it worked.
Does it show the folder names?
Yeah, so I think we can see it detected 3
Oh,
packages.
Topic publisher. Topic
Right, so now I can show. So what happened, like, that was a publisher code, right? Let's go into the subscriber code.
So like this, I think like we can take any application from the internet, just copy paste, and we can.
Mostly, yes. So this is subscriber, again very simple. So subscriber have something called as a callback function. So because subscriber have this concept of every time a message comes in, I need to do something, right?
Yeah.
So that is what subscriber is supposed to do. So callback is something that helps you do that. So every time a message comes in, I'll call this callback function. That's what it is actually called, like in C++, right? So let's look at what I have to do in subscriber. Again, everything is common. These 2 lines should be there.
Lines, yeah.
These 2 lines and then these 3 lines. They are very similar. They will always be there. This time my name of the node is different. Topic subscriber. That is what I'm calling. Then subscriber. That's how we are defining subscriber. What I'm subscribing to. Counter. Counter was the name of the topic that he was publishing on. And counter callback. So okay, once I'll get the message, what function I'll call. So I'm calling counter callback. So it will call this function every time. So all it is doing is it will publish that thing.
Awesome.
Not publish, sorry, print on the screen. So ROS info is actually very similar to printf,
Yeah.
but it's more than that, because you can have ROS info, ROS debug, ROS critical, ROS error. So that is the seriousness of the message. So you can actually filter. Okay, publish only the ROS errors.
Yeah.
So you can have multiple messages here, info, debug, and all. But if you are interested only in fatal messages, then you will say, okay, just print fatal messages, and you'll not see all this garbage that you will like. And if you do printf, it will publish, like, write everything, and you'll have to do it manually. So that's it.
Yeah.
That's pretty good.
right? So okay, now everything is working. We can go and Control A. What's happening? Oh, Tmax is not working. So I'll go to Tmax. I'll split it in 3 because I'll be running 3 processes. I'll running ROS core first of all. Oh, ROS core is already working somewhere. Oh, ROS core is working here, but I was closing everything down. Okay, so now ROS core. So you cannot run 2 ROS cores in a single machine. That is what the error is. Already running.
Oh.
Okay, because that what ROS core is, it's a single node that will be maintaining, so it does not allow multiple ROS cores. Okay, now the first thing I'll bring up is,
What does this say? Bash and then Python at the bottom on the green line.
oh, that's the tmux functionality. I can write commands, but that's a tmux thing.
So I'll open publisher.
Yeah, first let's open let's open I think subscriber first. ROS. Okay, I need to do one more thing. So okay, let's see. ROS run. This is how we run a node.
Okay.
And then the name of the package was topic publish. I think
Subscriber.
source
Publish.
topic subscriber, right? So topic. Okay, it's not working. Let me show. So
Will
what?
CD or source?
Yeah, I'll have to do something called a source. Source devil setup.bash. So what it is doing is, it is actually adding all the packages from my local package to my path.
Okay.
So this is where devil folder is used, so that have the path to all. So now it should work. ROS run. What was the name again?
I think
Topic.
it's spelled.
ROS run. Topic. Yeah.
Subscriber.
Right. Subscriber, and again tab. It will also tell me what node I have. So it ROS helps us in more than once. Okay, so I typed it. It's working. Nothing is coming. Right?
Now I'm here.
Why is nothing coming? Because I'm not publishing
Sending it.
anything. Again, ROS run. Topic. Nothing coming. So I'll have to do source. Setup.bash. ROS run. Topic. Publisher. And then now we can see my subscriber is reading the messages that I'm printing from my
Those
publisher.
are just messages numbers.
Yeah, so
There's
what?
no message in it, right?
Oh no. I'm actually, the message is the number.
The message is done.
Where did you define that?
Oh, here.
In the publisher.
In the publisher, I'm printing it. Okay, here.
Can you open that code and just add some text to each message?
It's-
Yeah. So that's
So we see what's
Where-
happening.
Yep. So that's the tricky part. So I'm publishing a number
Yeah.
on that topic. So I cannot just edit text. So I'll have to modify a lot
Yeah,
there
okay.
in there. So you understand? I'm not publishing a string there.
Or in the callback function, you just say printf ABCD or XY.
Oh yeah, definitely we can do that. We can change things.
Just in the callback function.
Yep.
add one
Yeah,
to-
let's do that. Let's do that. So I'll go to what? I'll go to here.
Subscriber.
Yeah.
Yeah.
Okay. So Control A.
So every
Let's
time
try.
it reads a message, just say, okay, I read one thing. I read one, I read two, something like that.
Okay. Let me just go. Yeah, that is something that we can do actually.
Okay.
And-
I read percentage D and counter.
I Detroit source topic subscriber and callback. That is what we'll
Yeah.
modify. That's correct.
Open this and that callback. Add
Oh,
one,
wait. I'm not good with this.
or Gmake.
Yeah,
No,
Nano is good for me, but not Vim. Other
Neo.
applications. Notepad ++ is fine. Okay, so in the callback, I'm saying I am
I received. Or something.
okay. I'm receiving. I receive actually. Okay, I did that. What I need to do is first thing first.
Make again or what?
Yep. Catkin. So see, it is only changing the topic subscriber because I only changed that. Okay. Now I'll go here. I'll do Control C, and I'll run topic subscriber again. Publisher is already working, and we can see I received number.
Nice. So when you make changes, it doesn't all the way start from the beginning. That's a good thing. So
Yeah,
it
that's-
starts
yeah.
from wherever. Wow.
That's why these build function, or else like
Same function.
my like the thing that I work on, it takes like 1 hour to build. Like if you are building from scratch.
So when you kind of made that change and for the thing subscriber to make the change, it kind of lost some data, but it was stored in buffer and then you put it back on the subscriber.
No.
Maybe I'm just thinking like
But here it's pretty straightforward.
It's Yeah.
straightforward,
It's,
yeah.
See-
it's not losing anything.
Yeah, it is not. So see, I'm stopping the subscriber again.
The subscriber
Right, 418 was the last number
Publisher
that
on
got
the
published. So let's wait for
Yeah,
like
but now the publisher is still sending.
yeah, publisher is sending, and,
So it's in
and
the
that number is
buffer.
increasing.
That's stored in buffer.
The
No.
buffer is too large. For 1000
Yeah.
numbers, I think you should wait for 10 minutes or something.
You don't concern with buffer for now, miss. I told you, but that's
Just make the buffer size 10. And
now. Let's see. I waited for like I think 20 seconds, and I'll run. So I'll get like okay, 30-35 seconds. So I'll get like 70 plus. Like okay, so I should get like 50. Oh, like 500. I meant 500. Sorry, not 50.
Okay,
So
that
it was
is lost.
Uh-huh.
That much is lost.
Yeah, because we were not reading at that time.
But wait, so then what is buffer doing? I think when it I thought buffer will store that and start.
It
And
does
then-
store, but you will like when you are reading, when you are asking, you're requesting for a message, you will only get messages published after that. So there is a possibility that why will you want to read messages received like 15 seconds before? So that buffer is there for
it's
like
real time. This is
it's
real time.
for even for maintaining that real time thing. So, but yeah, you need not to worry about buffer. That's like not a basic concept.
But it's an important one.
It's an important one for production.
No, like I'm just thinking if we are doing this in case of a debounce counter, like I don't know if you've heard debounce counters, like for error calculation for DTC, you will see how many times. So there are some specific errors which you will set a DTC or something, or you'll trigger a emergency situation only when the number of errors cross like 100 times, like 10 times or something like that. In that case, when I'm just taking this counter as counting the number of errors,
Suppose you're doing that.
yeah,
Mhm.
and if I lose how many errors happened,
Mhm.
I would be failing to trigger a emergency
Oh yeah,
situation.
so you will not be.
I'm just saying,
Mm.
so that
So this is not how you will frame your problem. You will be publishing that number itself. So right, so you'll be publishing the number of errors itself. In that case, you'll not
Okay.
be publishing individual counters,
okay.
and you will not be adding it here. You'll be publishing the number of errors at the side of source
Yes,
itself.
yes, yes,
And then suppose you got like 1 error, 2 error, 3 error, 10 error. Now I'm not reading 10 error, but it will continue to publish 10, 10, 10, right?
Yeah.
So you'll frame your problem in a different way there.
Yeah, now I- well, this is amazing. It's good.
Right?
We should probably do this. Next time.
Okay,
We can
cool.
Start from here. We should do this. This is great.
I'll need to go through this again.
Okay, I have a
There's a
silly.
lot of-
Yeah.
I have a silly basic question. Is there
Uh-huh.
any way you can save your terminal?
He recorded the whole.
No, but
Let me
like
see. I can, as I have my terminal. Like, let me see if I have the command go to positions. So see, I use tmux. I should like if you wanted to save the terminal, I should not have used that.
No, like in my case, now I didn't use tmux. How do I save a terminal? There's no file you can.
Oh, history. Type history.
Why do you want to save the terminal?
History.
So that next time I start from here.
Oh no. You will not be able to do
I'll not be able to do that.
But you want to save your commands? What you
Yeah,
have,
yeah.
Then do history, and
Like,
arrow key.
I understand what makes you save.
Just type history.
Yeah. Enter. So this is what you will be saving, right? But this will have everything that you have run.
Okay, so it will be saved.
Yeah. So not now, but you will be directed to some file that you want to save it. History and arrow it to. Like let me show you something like this. History. I am saving it to my commands .txt. So I saved it there, and now I can do gedit. So tilde brings you to these are all the commands that I have run.
My ROS.
Okay, cool. So tilde brings you to your home. So wherever I am, if I do this tilde, then I'll come to home. That's it. That's
So
what
where
tilde
is
is
this
doing, right?
Under SRC.
And normally you need not to remember like. And I have my IT-Detroit folder there.
Are you doing stuff with CUDA?
CUDA, that's for like TensorFlow and all, right? Yeah.
That's for the NVIDIA.
Yep.
I think
Yeah,
TensorFlow is written in C++ or C.
The backend is written in C++.
Yeah.
They definitely use it.
But CUDA is the language for NVIDIA's.
For GPU, yeah.
Yeah, that's what I'm just saying.
I learned it like a little bit, but I am not getting time. But that's a very good.
Ooh, can I show you?
What do you have?
Oh, do you actually? I don't know if you have this. So I got some radar data from that I was
Oh, let
doing.
me stop this.